Okay, so here we have a thermodynamics question. And I'll just kind of summarize it here. So we've got 0.6 kilograms of aluminum with a temperature of 80 degrees Celsius. Also, our heat capacity for aluminum is going to be 0.900 joules per gram degrees Celsius. We've got 0.3 kilograms of copper at a temperature of 70 degrees Celsius. And our heat capacity for copper is 0.385 joules per gram degrees Celsius. And both of these are being placed in 1.2 liters of water at a temperature of 20 degrees Celsius. The heat capacity for water is 4.186 joules per gram degrees Celsius. And we're going to assume that the density for water is 1 gram per mil, meaning that our mass of H2O is 1.2 liters times 1 times 10 to the minus 3 mils per liter. So not minus 3, but plus 3, sorry. 1 times 10 to the 3 mils per liter times the 1.0 grams per mil, giving us 1.2 times 10 to the 3 grams of water. So now all three of these objects are placed together, and the question wants us to calculate what the final temperature is. So the key thing here is that delta H for our system is 0 when there's no, if it's isolated, which we're assuming in this case. And so each of the components must sum. So for the copper, it's going to be just MC delta T. Or actually for each thing, it's just going to be MC delta T. So I'm actually just going to take that off because it seems kind of pointless. So each of our delta H's is just going to be MC delta T. So we just need to sum to get our delta H for our system. We're just going to sum over each of the component delta H's. Okay, so then we have our water, which is M water, heat capacity for water, delta T water, plus our copper, plus our aluminum. And now we can plug in some values. So for water, we had 1.2 times 10 to the 3 grams. Our heat capacity was 4.186 joules per gram degrees Celsius. And our delta T is our final temperature minus our initial temperature, which in this case, it's fine to use degrees Celsius, as everything is in deltas anyway. So that's our water. Now our copper, 0.6, 0.9, T minus 80 degrees Celsius. And our aluminum Okay. And the T here is always our final temperature. And so then all of this equals 0. Now, we can collect some stuff and rearrange. So I'm going to collect all the terms in T and do out all the relevant math. So what we end up with is T times 5.6787 joules per degree Celsius is equal to 151.749 times 10 to the 3 joules. Okay, so just collecting and rearranging to get to this point, and so that we can solve for our final temperature as 26.72 degrees Celsius. And so then there's our final temperature. And we should always check to make sure, especially in a question like this, and I think that makes sense, we have significantly more water, so the temperature should be pretty close to the water. If we check the solution here, basically the same. And so then it comes out to be 26.72 degrees Celsius, so that looks good.